Welcome once again to Chemistry Meal. Today on Chemistry Meal, we are still on the concept of chemical equilibrium. This is part 3 of the concept of chemical equilibrium. And today we want to look at factors affecting a reaction that is in equilibrium. So factors affecting chemical equilibrium. Subscribe to our YouTube channel and make sure that you follow us on Facebook at Mathematics and Science Meal. Alright, let's begin the business of the day. Let's begin this business quickly. Alright, so there are 3 factors that can affect a system that is in equilibrium. There are 3 main factors that can affect a system that is in chemical equilibrium. These factors are, what are these factors? These factors are, one is, okay, let me say pressure, because of the space it can contain it, temperature, and concentration. So these are the 3 factors that can affect a system that is in equilibrium. You remember that when we looked at the Chatelier's principle, we said that these factors are disturbances. They are constraints. So they are constraints to the equilibrium position. So these are the 3 factors that will have effect on a system that is in equilibrium. I also know that so many people will be asking, what of catalysts? Because they are using the mindset of rate of chemical reaction. We have explained in our first video that catalysts will not have any effect on a system that is in what? In equilibrium. We have said that catalysts cannot affect a system that is in equilibrium. We said that catalysts can help a system attain equilibrium faster. But once that system attains equilibrium, once a system is already in equilibrium state, then introducing a catalyst will not have any effect on that system. So in this video, we will not be looking at the 3 factors. We'll just look at only one. We are going to pick temperature in this video, and we'll look at the effect of temperature on a system that is in equilibrium. Remember that when we looked at Chatelier's principle, we said that equilibrium position will always shift. Yes, it will always shift in order to cancel the effect of the disturbance of the constraint. So they will shift to the right or to the left. So these factors will always make the equilibrium position so either shift to the right or shift to the left, depending on how the factors were introduced in a reaction, in a given reaction that is in equilibrium. So let's look at temperature. The first one, let's look at temperature. Now I'm going to give the effect of temperature on a system that is in equilibrium, and then after giving that effect, I will give further notes that we must take cognizance of. If you fail to understand the notes that I'm going to give, you will find it difficult to actually understand the effect of temperature on a system that is in equilibrium. So the effect of temperature effects of temperature on a chemical reaction system in equilibrium. Are as follows. They are as follows. On a chemical reaction system that is in equilibrium are as follows. 1. Increase in temperature favors endothermic reaction. Then decrease in temperature favors exothermic reaction. That's it. Thus, when temperature is increased, the equilibrium position will shift to the side that is what? Endothermic. While a decrease in the temperature we shift the equilibrium position to the side or direction that is exothermic. So, when temperature is increased in a given reaction that is in equilibrium, it will favor endothermic reaction. While decreasing the temperature will favor what? Exothermic reaction. So when you increase temperature, the reaction will move in the direction that is endothermic. So if the right hand side is endothermic, increasing the temperature will move the reaction to the right. If the left hand side is endothermic, increasing the temperature will move the equilibrium position to the what? To the left, and vice versa. That's what will also happen if you are decreasing the temperature. If you decrease temperature now, it will favor exothermic reaction. It will favor exothermic reaction. That means when temperature is decreased, the side that is exothermic will be favored. That means the equilibrium position will just shift to that side that is what? That is exothermic. But let's note the following concerning a given reaction. So let's take note of the following. Number one, every reaction will either be endothermic or exothermic. So we know that when reactions occur, we have heat changes. Yeah, we have heat changes that must accompany a reaction. So the heat changes will either be positive or negative. That is, whether heat was absorbed from the surrounding or whether heat was given out to the world surrounding. In a chemical reaction where we have absorption of heat from the surrounding, that type of reaction is said to be what? Endothermic. But when reaction was given out to the surrounding, the reaction is what? Exothermic. And we know that there are other ways of identifying endothermic and exothermic reaction. In endothermic reaction, the delta H, change in enthalpy or change in heat, is positive for endo. Endo is positive. When you do heat changes in chemical reactions, you will understand this. But for exo, the change is what? Negative. It's negative. For exothermic reaction, the change in enthalpy is what? Negative. That's how to identify endothermic reaction and exothermic reaction in a given what? Reaction. So, number two, second thing we need to note, in every reaction, the enthalpy change is usually written at the end of the equation of the reaction. So when we have a reaction, we usually write the enthalpy change of that reaction at the end of the equation. For example, if I have a reaction A plus B giving me C, at the end of the day we have delta H. Let's say we have delta H equals plus S kilojoule maybe per mole, something like this. Now this is the enthalpy change of this reaction. Now this enthalpy change, the enthalpy change indicated in a reaction is the enthalpy change of the forward reaction. So the enthalpy change indicated in a reaction is the enthalpy change or heat change for the forward reaction. So what it means in this reaction now, the forward reaction is endothermic. Yes, it's endothermic because this is positive. So this particular enthalpy change given to us is that of the forward reaction. You notice that they don't normally indicate that of the backward reaction, but we are going to explain what will now happen if you want to know the enthalpy change of the backward reaction. So in this case now, the forward reaction is endothermic. Why endothermic? The enthalpy change is what? Positive. Now, triple I. Let's look at this now. If the forward reaction is endothermic, then the backward reaction will be exothermic. If the forward reaction is endothermic, then the backward reaction will be exothermic. In the same way, IV, if the forward reaction is exothermic, let's for space sake, is exothermic, then the backward reaction will be what? Endothermic. So if the forward reaction is what? Endothermic, then the backward reaction will be what? Exothermic, and vice versa. So I don't want to use vice versa. Let's still make this statement because maybe someone may not understand what we mean by vice versa. So if the forward reaction is exothermic, then the backward reaction is what? Endothermic. That means in this reaction now, this forward reaction is endothermic. That means the backward reaction will now be what? Exothermic. In other words, the enthalpy change when you are coming back here now will be minus what? X. So on this side, when you are moving backward, the enthalpy change becomes minus X. So if the forward reaction is what? Endothermic, the backward reaction will be what? Exothermic. If the forward reaction is exothermic, the backward reaction will be what? Endothermic. So the final point, which is one of the most important points, that means the only thing that will determine the effects of temperature on a system that is in equilibrium is whether the reaction is what? Endothermic or what? Exothermic. Thus, the basis of the effect of temperature on a system in chemical equilibrium is the heat changes. The heat changes of the reaction, or is whether the reaction is endothermic or what? Exothermic. So what you will look out for, you are not looking at the reactant when you want to look at the effect of what? Temperature. What you are looking at is the energy change. So you need to know, is this reaction endothermic? Is it exothermic? So once you understand that, you don't have any problem, because already we have said that when you increase temperature, it favors what? Endothermic reaction. So anytime you hear increase in temperature, what will come to your mind is, where is the endothermic reaction? Which side is endothermic reaction? That's the side that will be favored. When anytime you hear decrease in temperature, it favors exothermic reaction. So if temperature is decreased in a reaction system that is in equilibrium, if temperature is decreased, look for the side that is what? Exothermic. That will be the side that will be what? Favored in that reaction. Okay, I think we need to take an example. I'm going to use one of the popular equilibrium equation talking about the Haber process, the industrial production of ammonia using nitrogen and oxygen. So let's nitrogen and hydrogen rather. Consider the equilibrium reaction below. Consider the equilibrium reaction below. Okay. So let's look at the Haber process plus hydrogen, so a gas also, giving us ammonia, which is also a gas. Delta H is actually minus 92 kilojoules. The reaction occurs in the presence of a catalyst, but we're not looking at that. This equation is not balanced. Let me just balance it. We are not looking at balancing of chemical equation. Okay. States the effect of increase in temperature on the equilibrium position. Okay, so let's answer the equation together. Let's do justice to it. Okay. All right. So consider the equilibrium reaction below. Consider the equilibrium reaction below. You said that's the equilibrium reaction. Nitrogen reacted with 3 moles. 1 mole of nitrogen reacting with 3 moles of hydrogen to give us 2 moles of ammonia, and the reaction delta H, the change in enthalpy, is actually minus 92 kilojoules. Now they say state the effect of increase in temperature on the equilibrium position. So let's answer the question. So the first thing, having looked at the effect of temperature on equilibrium position, you see that you increase temperature or you decrease temperature. So here they say when you increase temperature, what will happen? Now we'll go back. We have said that the basis of the effect of temperature on a system that is in equilibrium is on the heat changes, whether the reaction is exothermic or endothermic. And we say that increasing temperature favors what? Endothermic reaction. Increasing temperature favors endothermic reaction. So the first thing you need to do is to identify the site of the reaction that is what? Endothermic. Now if you look at this equation now, you will notice that the forward reaction is what? Exothermic. So if you are looking for the effect of what? Increase in temperature, remember, increase in temperature favors what? Endothermic. So which side of the reaction is what? Endothermic. That's the first thing you will have to identify. You can take note of this, put it down somewhere. If you want to identify, if you want to know the effect of temperature on a chemical, increase in temperature on a reaction that is in equilibrium, you must identify the side that is endothermic, because it is that side that will be affected by what? By increase in what? In temperature. So which side is endothermic? Since increase in temperature, according to our notes, increase in temperature favors endothermic. So which side is what? Endothermic. That's it. Which side is endothermic? That's the first thing we need to identify. So the forward reaction is already exothermic. How? We have said it, that the enthalpy change indicated at the end of the equation is for that of what? Forward reaction. So if the forward reaction is exothermic, it means that the backward reaction will be what? Endothermic. So if the forward reaction is exothermic, then the backward reaction will be what? Endothermic. So which side is actually endothermic, forward or backward? It is backward. It is backward. So increase in temperature favors what? Endothermic. And which side is endothermic? Backward. That means increase in temperature here will favor the what? The backward reaction. So increase in temperature will favor the backward reaction. Thus, the equilibrium position will shift to the left. We shift to the left, that's backward, because the backward reaction is endothermic, and increase in temperature favors endothermic reaction. So if you increase temperature in this reaction, you will produce less ammonia. Yes, you produce less ammonia. So in reaction engineering, we talk about the equilibrium conversion and the rest of them, but that doesn't concern chemistry students at this particular level. It doesn't concern them. Wow. So I believe that the concept of effect of temperature on a system that is in equilibrium is very clear now. Look for questions that treated the effect of temperature on a system that is in equilibrium. Go through the questions and see if you can actually answer the questions properly. Thank you for following us. Excuse me, let me take some water. So thank you for following us till now. In our next video, we are going to look at the effect of concentration. We'll see how concentration can affect a system that is in what? In equilibrium. What happens when you increase concentration and when you decrease concentration. Remember, concentration can be that of reactant or that of what? Product. All right, I will see you in our next class. Make sure you share our videos. Always leave a comment for us. It is important for us. If you have questions, just send a mail to us at engineericolysis@gmail.com, or you can send a mail to the number on your screen, 080 a message, WhatsApp message, 080870012 and then 56. We will attend to your problems. Thank you and God bless you.